In this episode, we're getting ripped. Wait a second. 3 pounds? Only 3 pounds? Oh. So for the rippers, pretty simple operation here. We're just going to make it more realistic. So let's get started on making a removable shank. So the part that I was just working on is what's going to be the hydraulic pin puller. I left these two little pieces on here because I'm not entirely sure if that's part of the pin system or if this is attached to the frame as a guide for that pin. So I was going to try to keep this little thing right there. That's what this screws down to, because it's a little bit wider than the 2mm slot that I was putting in there, but I think it's just going to be more of a hassle, and I think it's just going to get so weak that I'm not even going to be able to use it anymore. So I'm just going to drill it out of there, get it out of my way. And I wish I could use this milling bit up here, but because I have these two channels I have to drop down through, it's too wide and the bit itself isn't long enough. So fortunately I'm going to have to just go the normal drill style, but at least this part is slotted out, which gives me a nice foundation to start with. It looks really good. I hope my wife likes the smell of WD-40 because it smells like it. It also smells like success. You're right, this is the second ripper. Some of you may recognize this. It's the ripper from the D11 carry dozer, and Cat offered 2 single shake rippers for the D11. They carried this one and then the standard ripper. So like with the other one, I'm going to cut this out, but we're not going to do the hydraulic pin puller on this one. It's just going to be a standard pin. First I've got to take it apart, drill that rivet out, then these pins will pop right out as well. Alright, so the slots have been cut into both of these, top and bottom. And I've made templates for the rippers out of cardboard. This is just a thin, rigid cardboard. My favorite type to use for making templates. The tips were kind of based on the ones that I already have. I had to grind this one back just to get the profile of the actual shank itself, and then later I will make the piercing tips and then the little guard that goes on the standard ripper. And then I traced it all onto some thick brass and then rough cut it on my bandsaw. And then I'm gonna take it over to the old belt sander and clean up the edges, and then we'll start creating the little hydraulic pin puller, and then this one will just be a manual pin. Alright, the shanks are done and I'm happy with the results. They're not done, but they're done. Shanks are done. The accessories for the shanks are not done. So we got our carry dozer style ripper set up here, and see we got a little bit of play with it, which is good. Be able to put it in a few different positions. I can't put it much lower than this because once it falls out of that top there, it's going to flip-flop around. I could put things in there to make it so it doesn't do that, so I can drop it lower if I want to, but honestly, for being displayed on a shelf, I'm not going to put it any lower than that. It's a little bit of it sticking out the top and about right there in that position. And I don't think these are going to lift high enough once you guys see the modifications that I made to the hydraulics to allow that. But I will be able to pin them up or put them in upside down for, it's hard to line this up, for transportation. And then the standard shank is done as well. This one allows a lot more freedom of motion. I'm stuck. Next thing to do is I gotta grind all this off. That's like the imitation pin grabber. You can take that off because this one's gonna be a manual pin. And then I have to punch the hole in this one and then start building that mechanism too. Alright, now it's time to drill the through and through 2mm hole. It is time to punch the holes in the shank. I'm going to see if I can use this as a guide to line the holes up. The first stage of building the rippers is complete. You can see I'm able to pin the shank in. This one's a little bit firmer because I need it to stay in place. I'll show you guys how I'm making the blade guards here. So we have the basic shank, and I have this little piece that I cut that fits in there, and then the little sides will get soldered on. Put those into position here. So both the sides will get soldered on, and it will basically be a 3-piece to make the guard, and then we'll go in and bevel these edges, give a little bit more realism, and then I will make the tip in a similar way, but I'm going to probably use plastic instead, and I will make basically the outside detail, and it'll be a two-piece system, sort of like the way that these were already cast. This ripper is the one that went into the big CD single shank, and I noticed that it doesn't have a blade guard on it. I don't know what they used for the reference photos, but when I went through a lot of photos of D11s, both from the factory and ones that people are currently selling used, I did not find any rippers that were like this without the edge guard. The only ones that I found without the edge guard were ones that lost the pins and lost the guards somewhere in the course of duty. But most all the rippers all had the edge guards, and you can even see these little dimples here where I imagine whatever photo that the Northcott engineers were looking at when they designed this thing probably was missing the edge guard, because this is where it would have pinned into place with those two holes right there. So I'm gonna be adding the edge guard back to the blade, and then we'll be doing the same thing for the standard D11 ripper as well, the three-piece guard system, and then I'll drill holes in it and make it look a little bit more realistic. And in the meantime, I also did finish the pin that's going into this. It started out as a 2mm brass tube, and then I put a piece of 1.5 and then 1mm brass into it, and then put a little 2.5mm collar on there so it can drop in and hold itself in place. And then once the ripper's in, it actually puts some pressure on this pin and it holds it in. It doesn't fall out. In fact, I have to put a lot of pressure on it to get it out, which makes me think I'm probably not going to be able to paint the end of this, because it will probably come off, the paint will come off as I punch it in to reposition it. Alright, the first step of the guard is done. Soldered it in place. Got some cleanup work to do, obviously. And then I have to bevel these edges to give this more of a sharp leading edge. But it came out pretty well. So that was the three pieces, and I just ground it all down. You can kind of see before and after. This is after, obviously. And just drilled little 1mm holes in there, and then put some 1mm rod down in there to look like the pins. Alright, so while the rippers are curing, I'm going to get started on the mechanism for pulling and moving the pin around. And so you guys remember a little while back, I was trying to figure out what these two little points were on here. Well, I've through a bunch of photographs realized that they are pivot points because this fulcrum, as this raises and lowers, it raises and lowers at an arc. And because this pin has to go straight up and down, there has to be something to take up the that change in distance. So that's what these little guys are that I just made, are those tiny little pins, or not pins, but brackets. So here's our pin with a 1mm rod going through it, and then I'm gonna put these little guys on there. All right, first one on. My high-tech pin press here. This is the same method I used to hold all the pins in place on the Caterpillar track loader project that I did. Cool. Fantastic. Right after many minutes of fidgetry, I do believe the first stage of this is ready to go. All I need the pin to move is just that really short distance, about that much. The pin's out of the way, the mechanism is open, and it is closed. Let's take our not yet finished ripper. Let's see if it works. Nice. The next step will be rigging up a hydraulic for it. That's awesome. I'm really happy with that. Yes. That's rad. I love it. That's so cool. I think that's the smallest mechanism I've ever built for a model. After looking at this when I finished it last night, I wasn't really pleased with how it came out. I thought that it looked kind of janky, if you want to use that term, with just the square bar going across here. It just looked really basic, like somebody had made that aftermarket. I wanted it to look a little bit more factory, so I've taken it and I've shortened these two brackets that come off of here. They're shorter by about 1 millimeter in total length, and the holes are closer together by 1 millimeter as well. And then I'm going to be completely redoing the bar that goes across, and I'm making it from scratch using a piece of a little bit of plate here, and I'm going to run some tubing through it. The tube will be cut out to the distance between there as well as the distance between there, and it will be installed here. This will be cut out into more of a more realistic shape. So I'm going to knock that out and I'll show it to you guys after the fact. So this is a little piece of bar that I showed you guys earlier. I drilled 1.5 millimeter holes in it and ran this 1.5 mil tubing through it. So this is the side profile. What used to be that nice big square tube is now this, so that would go in this direction. And then the point where the hydraulic cylinder is going to attach, I created this little, it looks like the zoom is going back to the background. You can see that little notch right there. That's where this pops into, like that. And that's going to get soldered on. And then this back section, I'll fade all of that in so it meets up nice and clear. And that will be the finished piece. Alright, I am really glad I redid this. Went from just a basic piece of brass bar to this. Looks a whole lot better than it did. I'm glad I wasn't lazy and took on the challenge of trying to make this look a little bit more realistic, and it turned out great. The range of motion is a little bit tighter. You can actually see down in there, you can see the pin. It came out really good. Really pleased with it. The next thing to do will be create the cradle in the back that holds the hydraulic. This cylinder is a little long, so I'm going to shorten the whole thing up, but basically it will be in place right there. And I'll have to set it back a bit, so it'll be shortened, probably about that short, because I don't need a lot of motion out of it, just a little bit. I've finished mocking up the hydraulic pin puller for the ripper. You can see that's going to get clipped down later. I still have to strip all the paint off of this. And if you look around the back, you can see the little hydraulic that's in there. And let me support the ripper so it doesn't go flying down. Functions. Move the ripper around. Reposition it wherever you want. Lock it in place. It's good to go. I want to show you guys the changes that I made to the hydraulics on it. It previously came with much shorter lift cylinders, and you can see the difference between the previous one and the one that I've put on here. It's kind of hard to mock it up, but it should give you an idea. I robbed these off of a broken D8, and I also put them on the other one. They are a little bit longer, so the ripper is not able to retract as. Now, as you guys can see here, the ripper is not able to retract as high, which isn't a big deal, because by realigning this, I was able to make it so I have more freedom of movement in the angle of it. So with it in the full up position, that is as far as that one will tilt down, and this is as far as that one will tilt down. As you can see, you get a little better angle out of that. And then the way this came, that is as far up. Oh, I already popped hydraulics at. And we're back. Technical difficulties here. That's as far back in that angle as that will go. It's really limited at its top range. However, this one, I've modified it so that it will go all the way back. It gives me a much better tilt. So, one of these guys back up with the grid. So it still has enough to clear the ground, and if I absolutely need to, I just reposition the ripper. problem solved. Now, the main reason that I replaced these hydraulics is because of how much this is limited in its downward direction. That is as much as that can go out. Any farther and the pistons pop out. This was designed as a desk model. In this position, the ripper touches the ground. You really can't lift the model that much off the ground with the ripper. So if you were to take the ripper out and maybe try to stage it in like transportation mode, you wouldn't be able to do that because if you try to push it down any further, these come out, and there are actually little limiters on the back of the model that keep that from going down any further. Well, in my modified one, I've since ground those off, and as you can see, we get a very realistic range of motion out of this. This was just barred off another model. I still need to grind that little bit off the bottom. It's just temporarily pinned up, but it's pretty close to how it looks on the machine. And these aren't rivets, it's actually 1.5 millimeter tubing that I put in there. And I think I could pop this off. It's just held in place with pressure right now. She doesn't want to come off right now, I'll get it off later. And then that little piece was just soldered in, so I cut like a little groove in here and then soldered that piece in. I forgot to turn the camera on when I did that. I got home from work and I was really in the mood to get stuff done, so I just knocked it out. Didn't film it, but it's pretty straightforward. So yeah, the rippers are pretty much done. I got a little bit of cleanup work to do on them today. I take that off there and paint strip them, but other than that, they're good. I took a little creative freedom on this thing. I've seen so many different versions of these shank guards that I just decided to design one that I thought looked kind of cool. I don't know how that would function in real life, but it looks all right. And then here's the other one that's more of a traditional style. So our basic D11 ripper is done. Finished up the tip and whatnot. A lot more of this will get done when I paint it. Looks like the stud that I put in there fell out, so I get to redo that. That's cool. Probably around on my workbench somewhere. You guys already saw all the hydraulics done. Just cleaned it up a bit. Took some of the detail off the bottom that didn't need to be there. And the whole back of this is glued in. So before I prime it, I'll probably give it a run over with the sander again. Paint is gone. And as we saw, the whole adjustment deal works. It's awesome. And then this is the other ripper, or bigger, heavier duty one. Installed the loops in the top there. That ripper tip is done too. All my hardware is in there. Back has been glued in. And then the hydraulic valves, what are these called? These are like the linear hydraulic control valve, I think is what it was called. I didn't have very good reference photos for these, so I had to take a lot of creative freedom in creating these, just based off the photos that I had. And later I ended up finding some really detailed photos of these things, and it's a much more complex thing than I feel like designing that fits on the head of a pinky fingernail. But I think it came out pretty good. 4 valves per side. So we have the lift valves and then the tilt angle valves, and then these 2 valves on the bottom will go to the hydraulic on their pin puller. This will actually just get fixed in place. All I did was knock a little piece of 2 mil tubing in there and put some 1 mil in the bottom, then ran these tubes through it. So if you're well versed in this part, you're going to be like, that doesn't really look like it, but it kind of does. I like it. It came out good.